Good morning, ladies and gentlemen. I'm very happy to talking with you all today about digital transformation and giving it a historical footing where it stands from the evolutionary point of view. So we have several different sections to take care. So why history is once we know the path, either technology or politics or science takes, it's if you do the dots, we are data science folks. So if we connect the dots, we should be able to at least see what is coming in the next year or next few years and be ready for the changes that will hit us along the way. And that picture is supposed to reflect the mirror, how the past is a mirror through which we can see the future a little bit. And history, computers, we all know that computers, the mechanical variety was invented and started by one Mr. Charles Babbage, and his daughter is more famous, Ada, uh, one of the first artificial intelligence language is named after her. And in this picture, we are seeing Alan Turing. He is a British person who lived during the Great Second World War. And he was entrusted with the task of cracking the code, Enigma code of the Germans. They were using the code to communicate military messages. And it would be a great advantage if they can decode. They knew how to decode, but it was, manual way of doing it with the existing mechanical calculators, whatever they had. It was taking a long time. Before that, the damage would have been done, right? So that is where Alan Turing, put together his mathematical genius mind and his team and came up with the one of the computers that was cobbled together and which did a great job. It was able to crack the code in time and give the allies an advantage. So as we move on in the history from World War and 50s and 60s, we hear names like UNIVAC computer, which later became part of the Sperry systems. Sperry systems was very popular in the later half of the 20th century, and their systems were widely used in the airlines industry, the mainframes. So here there is a picture, and you can imagine just to have a computer, they had a huge location with CPU sitting somewhere, storage somewhere else, and many operations were done manually, like loading the disks, etc. So this was accelerated. Initially, there were all vacuum tubes generating a lot of heat and occupying a lot of space. Then came along the invention in the Bell Labs in the 60s, early 60s, by Shockley and his team. Of course, he was a little weird person later on as a scientist. So the Shockley and team brought the transistor into the world, and that enabled all the electronic circuits to be made close to 1/10 the size. So you can imagine a radio, tube radio, the size of 2 feet by 1 feet by 1.5 feet, reduced to a transistorized radio, which is like 1 feet by 6 inches by 8 inches height. So that was a level of betterment that happened. And if you know, man landed in the moon in the late in 69. By that time, the circuits there were all having only transistors. There was no integrated circuits or chips as we know today. So the chips were invented. They were there, probably it was not used in the mission. And Texas Instruments was one of the first, was the first to put together several transistors, resistors, circuits together and call it as an integrated circuit. Soon it was called large scale integration, and later it was very large scale integration, VLSI. So in the late 70s came the microprocessors. So that means what we see in the room, a lot of it was available in a single chip, the size of a typewriter, with all the keyboard, little keyboard, which could take machine instructions and run. So that was Intel's 8080 and Motorola's 6800. We in the scientific and engineering people, they felt 6800 was a far superior chip, but commercially 8080 was more successful as the years rolled along. And these were the chips that was harnessed by people like Steve Jobs, Steve Wozniak, and later Bill Gates to build their personal computers with adding interface circuits and so forth. So around this time, on the data side, so far we've been talking about computation and hardware, etc. So what was happening to data? So in the mainframes, the data was held in either magnetic tapes or much earlier, probably even punched tapes. So these were stored in manually in shelves, just like paper folders, and were brought into the computer for two such things will be brought in, and some processing will happen and output will come, which could be a payroll report. So that's how the mainframes were being used for a very long time. That's called batch processing as against real-time processing. So Cords was a person working for IBM, and he published within the IBM journals his classic paper on RDBMS. And he spells out the 5 different laws which we had to follow to normalize data. Probably it's enough to follow up to the 3rd level of normalization. So that's, I'm sure some of you would be familiar with these jargons. I'm just trying to piece together all these for you in a very short time. Let's come to so this is how a disk would look like, massive. It could be 2 or 3 feet in diameter. And people, the computer operators had to be really strong. They need to lift it, put it, mount it, do all that in a mainframe. So later, when the relational databases came along, it paved the way for real-time transactions. Earlier also it was possible, but this made it popular in the business world. And everybody understood the need of not to have a proliferation of data in different departments, everybody maintaining their own things, and how to bring all these in a central database, which would help alleviate confusion. So the mantra there was a place for one type of data and only one. So that's where you have to store. You cannot have 2 different locations for the same kind of data. So later in the PCs came along, and that led to, again, a proliferation of data in individuals' desktops and departments, etc. And fortunately, the PCs were later strung together with the LAN network as we know of today. People like Novell, NetWare were the big players during the 90s. And internet further gave the boost for communication outside of the organization. And around this time, in the 90s, one of the few first ERP systems were written. Hasso Plattner, who is the founder of SAP, he used to work at IBM, and they had developed individual ERP systems for several big enterprises. And he felt, why not make it into a generic program which can be configured for each company in different industries. So that's how the ERP came along, and Oracle pretty soon joined the bandwagon. And Chainsys has its own ERP system developed starting in 2000, and it's called eChain. And later came along the cloud, and the seed for the cloud, of course, it was a buzzword in the universities for at least several years before it became a buzzword in the business world. So one of the first successful companies was Salesforce, which delivered its CRM on the cloud on a SaaS model. So Salesforce had the advantage of being not a huge core application. It's one of the peripheral applications, CRM. So they had the advantage of having it on the cloud and while at the same time tweaking it. And salespeople were good in demanding this software and that be used by them. And that's how Salesforce grew leaps and bounds in the industry. And yesterday, Craig talked about Jeff Bezos and how he laid out how any system developed has to share things in a clean, neat interface. And one of the popular ways is web services. And Chainsys definitely is a huge fan and user of that to make life good for our customers. And cloud applications came to stay for, following Salesforce. People like Oracle brought their huge ERP systems into the cloud, and they are very successful in that. And Chainsys has several solutions that tag along or complement the cloud implementations. So we saw hardware, software evolution, application software evolution, and now the big buzz in our industry is digital transformation. So it means different things to different people. It's not just one thing to do. So people in different industries, and we are doing digital transformation. They could be doing several of things that are listed here. So one of the things we should, or I felt, what is the core thing in a digital transformation is to connect better, bring things together in a better fashion. So in an industry or a business, we are dealing with people, processes, applications, and data. If these are all better connected, we have done a good job doing a digital transformation. So there are several ways, if you see the bullets on the left, several ways digital transformation is accomplished. If you want to bring people together, we saw that during the COVID and post-COVID, we are using, currently we are using the vFairs system of delivering a conference right over the internet, everybody comfortably sitting in their own offices and homes and delivering and listening. This is a very good example of connecting how the new technology today, which is part of the digital transformation, is connecting people. And connected applications, that has been there for a long time. When the ERPs came along, the inventory system, finance, supply chain. So at least all these different modules, which were earlier individual departments and each had their own systems. When ERPs came, these different modules were integrated, put together, so that transactions can be posted automatically into the finally the finance system needs to know what happened anywhere in the rest of the company. And connected data. So we will come to that little later. And one of the easiest way to go to a digital transformation is not to do everything ourselves. It's possible to look at what the vendors, different software vendors are offering, and moving and upgrading to the latest one has many of the advantages of digital transformation weaved into those newer releases. For example, Oracle Cloud applications, and how they can connect with the other important cloud applications to make business better, employees to do their jobs better, and companies to perform better financially. And Chainsys has several tools which would enable such connections. We are in the job of connections. And no wonder this conference is called Be Connected. The fifth question, whether upgrade to the modern applications provided by the vendors or build new ones, the answer would be yes to both. There will be great advantages in moving to the great offerings, and then also building either some glue software or additional specific things which are critical to the operations of a particular business. So building is also not out of fashion. So here everybody says digital. Digital as a word has existed as far back as 20th century middle or even earlier. Anything which is a 1 or a 0 is digital. And probably with the advent of Boolean algebra, the digital word was already there. But today it's come back with a more vigor in the industry as digital transformation. So in this digital, some of the companies were born digital. For example, many of the online superpowers of today, whether it's Amazon, eBay, and others, they took advantage of the internet for the reach that it can offer, and provided services and products online, and all their business was closely linked with their system. Their system was their business. It was not some business that they were doing and tracking it in another system. Their system itself was running their business. So those are the companies which were kind of a born digital, and they kept innovating and tapping the new technologies that came along. But other companies, whether they're traditional automakers, manufacturers, chemical industries, they were not born digital. They existed long before this digital buzzword came. So they have been in existence, and they are transforming to become a digital, gain some advantage by doing digital transformation. So here is some of the how data and data digital driven enterprise can help companies. So what we are saying here is if there are applications, they better talk to each other, and that's where Chainsys Data Zap helps there. If you're having data which needs to be connected and helping everybody, including the customers and their client customers, it better be clean. And that's where the Data Zen product, which concentrates on data quality management, which should be everybody's ongoing task. Just like we take bath every day, the data needs to be cleaned up in an organization. I think I'm running short of some time. So likewise, who can take better advantage of big data and analytics? So the B2C customers, companies, they are better positioned. They are the online giants, and they have huge data accumulated as part of the transactions they do, and they have access to the social media, etc. They are able to do the sentiment analysis, etc. big time. And as against a B2B company like a big um, you know, healthcare manufacturer making some big time X-ray kind of a machine. They do not have too many customers, not too much data collected. Of course, they have data collected in their shop floor, which can be subjected to all the modern data analytics. The more data you have, the better chance for good analysis and prediction. So some of the building blocks here are for a good transformation would be the secure networks, web services. Chainsys provides several of these as APIs and adapters, hundreds and thousands of them for several different popular systems. And we have the bots for testing and remote robotic process automation. So when you use, there cannot be one single application which will perform everything. So we earlier touched upon building some, assembling some of the best of breed cloud applications. They need to talk to each other. That's where the DataZap's data integration capabilities by orchestrating the adapters and web services provided by the Chainsys platform comes handy. So this is one example of a word which got transformed. Long back, we used to know a name by a word called seminar. We don't hear that anymore. Today, everybody uses the word webinar. What happened? The word got digitally transformed. So coming to the crystal ball, I have a feeling that a lot of focus will come on customer experience, making things easy and fun. Every workplace, the job will be done, but at the same time, it will be made really fun and easy for each player. All the tedium will be slowly removed, and technologies, programmers, and companies like us would be working towards that to make the business world more fun place to work in. And the portal-based applications are good, examples for things to come. Yeah, I think with that, I finish my talk, and I'm ready to take any questions. Thank you.
Thank you so much for that. I have a few questions from the audience. The first one is, in your opinion, is digital transformation a technology transformation or a people transformation?
Okay. So many of us who implement ERPs, we know it is people, process, and data. So transformation involves both technology as well as the people. So when the new technology is implemented, it's very imperative that we train the people to take advantage of it, and they feel comfortable. People not comfortable, many transformations will fail. Yeah, I think that answers that question. Both are important.
Okay, and then what examples do you have of digital transformation?
Good. So some of the examples I touched upon, moving to, say, for example, either SAP's S4 HANA, which is their newest ERP release, or Oracle's Oracle Fusion Cloud applications. So these come with some inherent transformational features. In the case of S4, the most touted feature there is you don't have to build a separate data warehouse or a data lake. You can perform analytics on the same from the same database as that of the transactional system. Transactional database and analytical processing happen on the same database without affecting performance of each other. So that's way of solving some of the problems. Instead of creating your own data lake, you're getting it by adopting something provided by a vendor. And similarly, the Oracle Cloud Applications also offers a lot of the advantages cloud applications provide, collaboration, etc. What was the question again? I hope I don't want to.
Examples of digital transformation.
So moving to the latest is a digital transformation, implementing good communication software, such as the ones we are using for this conference, etc., makes people more connected and perform their work in a better fashion. And also, most important is, as we grow into the best of breed cloud software, as we buy and implement in an enterprise, there is always a need for these things to be strung together, data sharing or screens flowing one to the other through a workflow. So there is a massive need for integration of applications. And that's one big area where Chainsys has excelled in and will continue to support our customers in those areas. Yeah, I think we could go on, but then let's take the other questions.
Yeah, there's one last question that we could take. This person says, please say more about Chainsys' focus on user experience, AI, and ML in the future releases.
Yeah. So as you know, see, our own platform is a cloud application. So we have, we host it in our own infrastructure, whether it is Microsoft Azure or Oracle Cloud Infrastructure or AWS, Amazon's cloud. And from there, we service many of our enterprise customers. And where data security is paramount, when our customers say our data cannot leave our premises, we have the agent architecture whereby we place our agent software within the secure network of the customer and make sure data doesn't leave the premises. So we are running in the forefront of the digital transformation, helping our customers in the way they want today and getting ready for the way they would like the tasks done in the future. And for example, even a simple thing as transforming, doing a data migration from legacy systems or one ERP system to another. So we have not only the product that can help there, along with the product comes the whole methodology, the steps and processes people have to take. The system itself guides them through that. So that is the level of customer experience that we bring to the industry. And that is the reason our customers like our products and services. And yesterday we had Senthil from Western Digital talk so eloquently about the migration in their office and how our software, help them in the best way possible.
Okay. Thank you so much for answering the questions, and thank you so much for giving this presentation. We really appreciate it, and we learned so much. Thank you to the audience for joining us this morning, and I hope to see you guys in other sessions. Thank you.
Thank you all. Have a great rest of the day with the nice sessions. Thank you.